case number 2, and this is constant velocity. And so when I talk about constant velocity, this is what we call dynamic equilibrium. So let's go look at this thing here. So what do we know? Well, it must be exactly in the same way. Static equilibrium. Why is that? Because velocity, if it's equal to a constant, then that implies that the acceleration is 0, which then tells us that the net force is 0. So that means, once again, forces must balance. So let's look at some examples to try to see if we can make this clear. So as an example here, suppose we push a block. So we push a block with our hand across the table. And of course, at constant velocity. So we'll draw 2 pictures just to make sure that things are nice and clean. So I want a surface here. So let's say that this is my surface. And now what I'm going to find here is that I'm going to have a block and what I'm going to do here is that I'm going to come in with my hand and I'm going to push with my hand from behind. So I'm going to push. This is going to be my pushing force. And because I know that the velocity is equal to a constant, that also means that the acceleration must 0. So the only way that this could be true here is that there has to be an opposing force. And what we find here is that friction always opposes the direction of motion. So in this case, that means that friction has to point in the opposite direction of the velocity. So then if it's moving at constant velocity, then the force of friction must be in that way right there. So what you're going to see here is that that's typically not the way I draw it. The way I typically draw it is like this here. So I'm going to bring this back up here. And the way I typically draw it is I draw it like this. I come in and I do this. I'm going to say what's pushing this thing in the forward direction is the force of my hand. And the force of friction is opposing the force of my hand. And one of the things that we're trying to see here is that these guys must have the same length. So this immediately tells us here is that F net equal to 0 then implies that the force of my hand must equal the force of friction. In other words, we say that these guys are what? Balanced forces here. So these are balanced forces. So this is a pretty interesting result. So let's try to look at this thing here. And so what we're going to do here is that we're going to do the following thing. If you are at rest, what this tells us here is that you feel no forces acting on you because F net is equal to 0. If you are driving at constant velocity, guess what? You feel no forces acting on you. And the strange thing about this is that because one is at a state of motion of force free, that implies that the acceleration is 0, and as a consequence, that net force equal to 0 implies that one cannot tell whether one is at rest or moving at constant velocity. Think about that. That is a wild statement, because what it's saying here is that you can't tell whether you're at rest or moving at constant velocity. And in physics, it's even stronger. You can't even do an experiment that shows that you're at rest or constant velocity. These two states are identical. And to try to show you what do I mean by this, I want to give you an example. Okay. So here's the example. So many years ago, before Santa Cruz or Watsonville got a Home Depot, I had to drive to Salinas to go to Home Depot. One particular morning, I drove, I went onto Highway 101, and then you get off at Highway 101 off of a street called Baranda, and there's an incline and you're right at a stoplight. So what you find here is that I am waiting for the light to change. So picture-wise, what do I see here? Well, there's an incline. Okay. So here's this incline, and right here, there's a stoplight. And so that means here, right, there's a red, a yellow, and a green light. But it was a red light, so I'm waiting for this thing to do that. And what you're seeing here is that this is what you find, that there's a truck on this thing. So there's a truck on this incline. Okay, so when I look at this truck, well, let's make this a green truck. And then there was my car. So I'm here also in my car. And so what happens in my car here is that we're both on this incline. And what you find here is that suddenly, as I was sitting there on, in my car, I felt the car moving. So then suddenly, I feel myself moving downwards. And I'm going, and so of course, what do? I go, oh my gosh, I fell asleep. So I slam on the brakes. You know what I found out? I wasn't moving. It was the truck that was moving. I wasn't moving. It was the truck that was moving. I couldn't tell whether I was at rest, right? So this immediately tells me here that I cannot tell the difference between being at rest or moving at constant velocity. And you got to admit, you probably have seen that situation, right? That is a really bizarre feeling. But that's what Newton's laws say, and that's where this starts to come a little bit surprising because you don't really notice these things.